Hey everyone, today I'm going to show you how to build an AI-powered image recognition application using AWS Services from scratch. We are going to start simple. I will start with an S3 bucket, a Lambda function, an Amazon Rekognition service. So what we do is you upload a picture and AI tells us or describe what is in that picture. That is part one. In part two, we'll take it further. I will deploy a full web application with a custom domain, a nice user interface, and automate the process using Terraform, the infrastructure as a code service, and GitHub Actions to manage the CI/CD pipeline. So everything is serverless and everything is automated. Now let's jump into the architecture. So this is the architecture, the simple version of it. It has the Lambda in its core. So what it does is once a user uploads a picture to the S3 is like a giant drive in the cloud. This S3 is event-driven. It has been configured to be so. So it triggers the Lambda service, passing the key of the image to the Lambda. Lambda calls the recognition service to read the object. Rekognition returns the object results as labels. Lambda writes those results to CloudWatch. The CloudWatch is the monitoring service of AWS. So Lambda is able to do all this because it has an IAM role that has three policies. The first policy enables Lambda to read results from CloudWatch. Secondly, Rekognition is able to inherit that reading role from Lambda to read what is in S3. That's this dotted line, denoted by this dotted line. So Lambda also has that result, also has that role or policy to call the Rekognition API, and Lambda has that third role to write the results to CloudWatch. That is the simple version of the project. But for the version 2, I'm going to add a user interface and then another Lambda that generates a pre-signed URL, meaning it generates a URL that has been signed already so that any user can upload a picture to the bucket. Secondly, it has a code that can call the API of Wikipedia to briefly describe who a celebrity is and also write that result back to the front end. That's the UI which you're going to see in the next few minutes. So now we jump to the console. We are going to get started. First thing is to create the IAM role for Lambda to execute the commands that we just described. So we'll call the role whatever name we like, create the role. So because Lambda is a service that's going to be performing another service or another duty on our behalf, so it's going to be Lambda EC2 role. So we select Lambda here and we create that role. So we have the option of creating inline policies, but the simpler method is just to add already approved or managed services, managed roles or policies by AWS. So we can add the read-only S3 read-only access. So Lambda can only read from S3. Also the Rekognition read-only service, our policy, Rekognition read-only, and then lastly, Lambda basic execution rule, the basic execution rule. So we can confirm if those three policies have been added. So these three policies are added already, and then we just name the Lambda Rekognition role for Lambda. And then I just create that. So I've created the Rekognition role for Lambda. The next thing I'm going to do is to create the S3 bucket. So I go to the bucket and create it. So create a bucket. It can be global, it can be account or regional based. So if it's regional based, AWS is going to assign your account ID as prefixes to your bucket. So I can call it my Rekognition bucket. So because this numbers are going to be there, the account ID, I won't bother because it's going to be unique and it's just regional. So I'm going to leave every other setting, leave ACL, leave block public access, so anybody cannot just access my bucket on the internet, disable versioning and leave that like that. Leave all the advanced settings and just create the bucket. The bucket has been created. Next, I'm going to create my Lambda service. So create a function. We can call it processor or processing Lambda. Can name it anything you want. Our code is written in Python. So I'm going to select Python as a runtime. Additional setting so that we can add the custom role that we created for Lambda. Add a custom role. We call it Lambda Rekognition. Yes, Rekognition role for Lambda. Save that. We'll leave the CPU architecture like that and every other setting, and we just create the function. Now the function has been created. Next thing, we are going to add the trigger. What triggers this Lambda is going to be the S3 we created. So look for the source as S3. I thought we named it Rekognition. Yes, this is the bucket we created. So which event types will trigger this Lambda is going to be pulled because we're going to be uploading. We can just add all create events, meaning any event that creates a new object inside the bucket will trigger the Lambda. So we'll leave every other thing, acknowledge this, and add to create that bucket, to create that trigger. So in the backend, AWS has added an event-driven configuration to S3 because we've done this in the Lambda console. So everything is now set. The next thing we need to do now is to add our code. All right. So I'm going to delete the base code here and go to my GitHub and look for the code. So I have two codes here, celebrity and image. One is going to describe an image, the other is going to describe celebrity. And then I've combined both to be in my version 2. So I'm going to add the image.py first. So this is just a bunch of functions and helper functions. So I'm copying this and paste in my Lambda console, and then I will deploy. So that is deploying and that is done. So the next thing is we are going to test this if it is working. So I'm going to upload an image to the S3 bucket and then confirm from Lambda to see if the result is there. So go to the bucket. I name it Rekognition. This is the bucket. So we are going to add a file to it. So let me first show the file. Because we are using the image, the object first, so I'm going to upload object 1. And this is object 1 name. So some ladies enjoying themselves. So I'm going to upload this. Upload, add a file, object 1 added, just upload. So everything is done in the console. So object 1 has been added. To confirm if Lambda has seen that, I just go to the Lambda service, go to monitor, and then go to the CloudWatch created for this Lambda. And let's just see. Okay, so this is a log stream. Open the log stream and go to the top. We've seen the results here. So the runtime, Python, the object 1 named, it recognized the face 100%. They are happy, head, they are laughing. It's a person, they are adults, they are females, they are women, and they are holding a bottle. It's described as alcohol or beer or beverage or hair. So these percentages are the confidence level of each of the labels returning. So for example, we can configure it in the code and say, if you are not confident up to 90%, let's just test our second object. Our second object is this, object 2, a nice picture, and amphibia. So go to the bucket again and upload the file. Object 2 added, upload. Object 2 is being added. Go back to CloudWatch and just refresh that and see if we have the object 2 detected. And just refresh again. Object 1 is still seen. So this is object 2 has been seen, has been detected. It's an amphibian, confidence level of 95%. Animal, the frog, wildlife, lizard. Okay, so 100% perfect. This is working. So what I'm going to do now is just to test the second code and of a celebrity. Copy that and just replace the code in Lambda with that. Go to the code, replace it, put the new code, and just deploy. It's deploying. Now that is successful. Okay, so I'm going to upload the image of a celebrity. This is Cristiano Ronaldo. I've named it player 1. So I'm going to upload that and see if our recognition service is able to recognize that. So upload, add file, player 1. Uploaded successfully. Go back to the CloudWatch log. It's going to be another log because code has changed. It's going to be a new log stream, most likely. So this is the log stream, the latest one. Okay, so it's finished running. Player 1, name is Cristiano Ronaldo. The confidence level is 100%. It recognized that, and Wikipedia fetched us that through the API. This that dash is a Portuguese player. So that's done. This is a celebrity. Okay, this is a basketballer, a popular basketballer. So go back to the image recognition and upload player 4 to the bucket and upload player 4. Player 4 uploaded is going to be the same log stream, same code. Let's see if we now have the second. So this is player 4, it's Michael Jordan. Confidence level is 100%, it's very confident, it's a male. And then it fetched the bio from Wikipedia. Michael Jeffrey Jordan, also known by his initials MJ, is an American businessman and retired footballer. This is done. So our recognition service is working perfectly. And that is a good one. Next, we are going to go to the version 2. Now for the version 2, I have the infrastructure will be deployed using Terraform. And then CI/CD will manage by GitHub Action, which I said earlier. Now, the basic thing that has been added here is that I now have Lambda packages. I have more than one Lambda, pre-signed Lambda that will generate the pre-signed URL for us. And then we have the Lambda processor and the one that will write the results. These are the now Lambdas that we have in this version. Okay, and then we are going to have a web UI that will be doing that for us. And we have a combined Lambda, a combined code, which will be running in Lambda that will help us to choose between the celebrity and then between an object. So we don't have to upload two different codes. It's one single code switching between two different categories. Now, going through the Terraform code, I have some addition here. Now I'm going to have a DynamoDB table that's going to store the results, because earlier the results are not being stored, but now the results are stored so that when they are queried, it will return the result of already processed Lambda. That's there. And it has a new bucket for holding my website buckets. And it has another Lambda role that does the pre-sign generation of the pre-sign URL. And then it has API gateway, okay, that does my routes for me. And then some permissions that helps Lambda perform its role. So this is the API gateway code, Terraform configuration. That's rate limiting, meaning that there's a rate to how much people can actually query my API gateway. So these are the code. You can come here to just pick this up and use whenever you like. So now let's just deploy this using Terraform and then using GitHub Actions. I go to my Actions tab. I have already run some actions which are here. So I just go to the workflow, or workflow, deploy infrastructure workflow, and then I can just run this workflow using a deploy. If I want to destroy, I just say destroy, and that will do that. So let me run this workflow and just deploy my infrastructure. So this will start running. So we're going to give it a few minutes. So finish running, and then we can see the result live. So it has started running, setting up Terraform. Now it's doing Terraform applying the configurations. 1 minute has elapsed and it's still running. So it has finished running. It's actually generating the output now and syncing the website files to S3. So I have already run this before, so I created a dispatch workflow so I can just run this from my GitHub Actions without going back to my Visual Studio codes to do that. And also sync those website files that we saw earlier. The website files, is sync them to S3, and then everything is set for me. Okay, so it has finished running. Now we can just go back to access our front end. If you look here, look at the live demo, you can access it here. And here we are, the image recognition service that we ran in the console is right there in the user interface for you. Okay, so a user can just come here to test. You can test, choose between celebrity recognition and object scene. The first thing I'm going to do is object scene, upload, like we did earlier, the object one. Open that. This is the object. Click analyze and let it analyze the picture for us. And let's see. So it has finished analyzing 30 labels, just the exact same thing, but now in a UI. So we have a face, 100% happy, they're happy, heads laughing, hair 73%. Okay, I can also upload and test the second object 2. Analyze the object 2 for us. And what's the result? Amphibian, animal, frog, wildlife. Okay, so I can also delete any of this. So I can switch now to recognition, to celebrity recognition. Upload a celebrity player 1, test that again, analyze that, and see. Okay, 100% recognized as Cristiano Ronaldo, is a male. And then from Wikipedia, all right, Dos Santos Aveiro, nicknamed CR7, is a Portuguese football player, He was named the World Player of the Year 5 times by FIFA. Okay, so we can do the last one, player 4, and analyze that result as well. So we have Michael Jordan, 100% accuracy, is a basketballer, is a businessman, and all that. We can always delete any of them if you want. Go back here, over on them, and just delete. And that has been deleted because the Lambda functions are actually working. So everything is working, a nice UI, everything automated for you there. So there are many use cases to this project. It can be used in e-commerce for labeling items when shoppers or when sellers have a lot of items that they've not named. You can upload all the pictures and ask Rekognition to put labels on them for you, and Rekognition will do that. This application will do that perfectly. We also have them in crime detection, and fraud detection as well. So this is actually a very useful project, and if you want to try it. Yeah, so there you have it. We went from a simple Lambda plus S3 setup to a actually production-ready web app with CI/CD, all serverless, all on AWS. The full source code is on my GitHub GitHub platform. The link is also in the description. You can fork it. You can swap it in your own domain and have your own image recognition app. You run it in your own way, whatever way, probably the minimal way or also the second version. A few things worth noting, however, at 100 uploads per day, that will cost you around $5 a month. It scales automatically, so you don't need to serve, no servers to manage. So API gateway throttling protects you from unexpected bills. So you can also follow, if you follow my code exactly, you're not going to incur any cost more than probably $5 in a month. You could even expose this as an API if you want for other developers to use. So you get the API, you just give it to them. So there's no need of this front end. The API developers can use it in their front end, in their code, and actually get the results they want or use it however they want to use it. So thank you. If you find this helpful, please hit subscribe, drop a comment. If you have questions or you want me to cover anything, probably the API keys authentication or that feature, I can also build that. Let me know in the comment sections. Thank you. See you in the next one.